I know we talk about those successful startups, and on our social media posts, we act like everything just went lovely, but probably this is more realistic of what your typical startup looks like. Bunch of cables. I can't remember exactly where I'm supposed to land. In between waiting on parts, I got a bunch of notes that I can't remember exactly what I wrote. And yeah, I just figured I'd hit the record button on some of this, and hopefully it saves you some time. So just like in my last startup and commissioning video, we all do it. I did it this time is I got all the major components, I got my encoder here. I got my IO-Link module here. I got my sensor up there and a stack light, and I got my pneumatic solenoids down here, and I got them all with M12 connectors. And then I go to hook it all up, and I go into my closet and I grab my bin full of cables, which of course doesn't have the cables I need. Which brings up a very good point. When you're purchasing your items, here's another reason to use somebody local is, yeah, you probably can get a little bit better deal buying something online, maybe buying it overseas. But yeah, I bought this Turk encoder, these banner sensors, all this SMC stuff from the same distributor. So when all of a sudden I realized, I need some help on this cabling, I called the distributor like, hey, will you come over and help me with cabling? And they did a really nice job. Got me all set up with everything I need to make it all clean. But I wanted to show you one item that may help you out while you're doing all your commissioning is, okay, now on a real machine, all your cables should be labeled. But I hadn't really talked about it. I'll catch you up on what exactly this machine is later. But on this particular trainer, there is zero labeling. And so I think I know which cable this is, but now I'm like, all right, I'd like to double check and make sure I hook it up to the right spot. So grab you one of your field wireable connectors, and actually these are really awesome because they got the little releases on them instead of us jabbing self with a screwdriver. And I'm just gonna put a jumper between the brown and the blue, and then I'm gonna screw it in this cable. And the reason I use the brown and blue on this is that is our plus and minus 24. There's zero chance that those would ever be shorted out if it was a switch or anything. And now I can take my meter in ohms on the other end, and I'm pretty sure it is this cable here. I'm gonna touch the blue, and then I'll touch the brown, and we get a beep, so this is definitely the cable. One other thing while we're on cabling is, in the end, we do want to have a bunch of tie wraps and make it look super neat. But especially during startup and commissioning, and actually on this machine, we leave it on because it is one of the unfamiliar machines where they might need to trace a wire, is start by just putting some Velcro on it. So you can buy these big rolls of Velcro, cut them to whatever length you need, and then we just Velcro them together. And then once we're sure we have all the cables where we want, usually we'll come back, put the tie wraps on, take the Velcro off. All right, I got all my cables except one landed. I didn't catch this is an M12 8-pin, so my gate switch is not going to work right now, and I have I have nothing to rob in here. I can't think of where I would have one of those. Also, yeah, it's just like your cars on the weekend. The hood's up on every trainer in here. But now that we have those tied up, I took a few minutes here, and yeah, I did clean up the area, mainly so that we can walk around if things go bad. Hopefully we don't trip over everything, and make sure, because I'm the world's worst about this, now's the time to count for all your tools. Did you leave any tools laying in the control panel? Because yeah, we're going to power this up. And since it's our first time powering it up, might as well record it. Hopefully it's uneventful. Fire in the hole. Okay, and that's exciting. It looks like we got power to our servo, our Ethernet switch, our power flex. Oh, got a good IO OK light there. Got some blinky lights there. Blinky lights are all exciting. PLC's lit up. Oh, that's even more exciting. We have a couple inputs. I'm not sure what they're wired to. I'll have to end up looking at the diagram. And, All right, so I have no power going to my IO-Link module. And already I can tell a few of you are getting ready to peck on that keyboard. Why do I have an IO-Link module right beside a discrete distributed IO module? So this is the replacement for our unfamiliar machine. So this is the machine It really simulates the brakes and simulates how to troubleshoot machines. It has no wiring diagrams, it has no wire labels, it has no anything documentation-wise. You have to figure all that out. And the goal of it is really just to sprinkle a little bit of what you'll see out in the field. So in this case, we had this IO link module, and over here we had a discrete block. So just so we can see the little bits of differences. So in this case, these are side by side for the same reason. So I'm gonna start by checking my 24 volt down here because really I felt, I felt I must have 24 volt down here. There, I got enough stuff lit up, it couldn't be a single wire. So between there and there, yes, we have 24 volt. All right, now you're really gonna be scratching your head because you're gonna be like, wait, what is this panel? So part of the unfamiliar machine is it can simulate brakes. So there were 40 switches on the side of this one to break different parts of the machine. And that actually mostly came out of this box right here to simulate different parts being broke. So this box is packed plumb full as we've added features. And so that was the big thing here is we added a bigger panel to simulate our brakes with. And while I got my jumpers up top, here is my plus 24 volt and my minus 24 volt. And I forgot to put the jumpers down here. So we need a jumper in here for a plus. And we need a jumper over here for our minus. Okay, and yes, I know y'all are looking at these cables being like, Tim, that's pathetic. But one, I'll either tuck these in or I will cut them shorter later. I really wasn't sure how I was gonna route these. I'm still not super happy with my routing. So I'm not sure what I'm gonna do. But yes, this will look beautiful by the end of it. Okay, that gave us some lights on our Turk IO link, and I'm gonna say this looks pretty happy. We have red on this one because there's nothing connected to it. I have red on this one, I'm about to figure that one out. And over here, I have at least one indicator light, so that probably means that one's good. And while my sensors need adjusted, it's always exciting when you see some lights, so yeah, if I move that right over top of it, I'm getting an indicator there. And apparently that's gonna be that input right there. Looks like my vibration monitor's got some lights going on. The encoder's got some lights going on. And yes, I know I need to do more than just be excited that the lights are going on. But let's face it, we all get excited that there are actually lights working, that we may have wired something correctly on it. So the next thing I'm gonna do is an actual IO check online with the PLCs. And I did say PLCs plural. So this does have a 5069 compact guard logics. And this is what they work with most of the week. But the brakes are actually simulated with a Micro 850 PLC, and they do end up working in the Micro 850 PLC near the end of the week. And part of that is so that you understand, if you understand good foundational troubleshooting skills, it translates from brand to brand. In fact, I'm not going to do it now, but really I should have put like a Siemens S7 1200 here. It would have worked just as well, and then they would have seen that they could troubleshoot Siemens just by learning Allen Bradley. All right, next generation will have to remember that. Oh, I may have opened my mouth too soon. This isn't good. We have a flashing red light on the Micro 850. And I connected to it in CCW, and sure enough, it has a little red X there. And I really wish they would make this a little more intuitive to get to. But yeah, we go here, diagnose faults, or you could double click there and bumble it through. Expansion IO, expansion IO, terminator missing. And yeah. Now, if you just use a Micro 850, the thing will work great. If you add expansion IO, you have to have the right hand end cap. Now, it's Sunday, so it's not like I can run and get a right hand end cap. Which, speaking of which, folks, we need to quit doing plant shutdowns on holidays because, yeah, you can't get any parts during a holiday. So it's Sunday, I can't get it. Actually, I just looked it up on the distributor website, and it's a 7-day lead. So really quickly, a small little item in this project could bring us to a dead stop. Now, luckily, I was able to steal one off of another one of our trainers, which of course means I have another trainer down now, and I'm gonna snap it in. And the 850 from the factory comes with this end cap. And so I forget every time because I end up popping that end cap off and just shoving it over here, but the inside of it, it doesn't have anything. The inside of the one you need looks like that. And so we simply smack that onto the side of it, pull the little levers forward to lock it in, or are they backwards? Which way do they go? Well, let's pop it back off. You push the levers back. So yeah, push the levers back towards the den rail. Well, I haven't even locked any of the levers down apparently. That would be great in a vibration application. Yep, we'll push all the levers back now. And don't forget, there's ones on the bottom also. Oops. Well, apparently I snapped the bottom ones in. All right, now I'm going to power it back up, and I'm going to show you a little trick, because mainly I'm laying on the floor right now, and I don't feel like getting up off the floor until I know this is fixed. My computer's not in sight. It's going to come back with this flashing fault light. And if you have the program switch, such as the Micro 850s, or actually your Control Logics, Compact Logics, pretty much all the Allen Bradley PLCs that have a key switch or toggle switch in this case, watch what happens here. So we're going to switch this to program mode, and nothing happens. We still have a flashing fault light. Now I'm going to switch it over to run mode. Still have a flashing fault light. Now the second time it goes over the program mode, notice our fault light goes out. And we hope that we switch it back to run mode. And when we get a run light, ooh, and we get some outputs on. And this really excites me a lot. Mainly we're getting some outputs on over here. Because yeah, this is how to simulate the brakes. And so without these outputs on, I can't get power to all the stuff that's supposedly broken. So on our old machine trainer, it was these toggle switches here. And this really, two things, it's the Achilles heel of the machine. Like one of these switches breaks, you pretty much have to abandon it because there's just no room in there. And that's a big old mess. And so that was one goal, was to fix that. The other thing is, when we're running this, the technicians could see when I flipped the switch, and they could immediately observe what happened, which typically isn't how you actually walk up on a machine brake. So this will be slightly more randomized, where they're going to have to pay a lot more attention instead of just watching me flip a switch and then seeing what happens. Okay, so it took me offline over here, but now we'll go ahead and reconnect to this one. Of course, we saw over there it was a solid run light, but still I'm going to check here and make sure. And in a second we should see, whoops, go over to the Micro 850 tab, or if you don't have it open, you can just double click on the Micro 850 there. And we can see that we're in run mode now. And so now, the other one is the Control Logics, or the Compact Logics, or Compact Guard Logics. I'll get it out in a second. So this one right here, we're probably going to have to work on this I/O a little bit. I did go ahead and configured all my IP addresses, which I'm sure y'all all know the easiest way to do. So I'm going to go to Communications, Who Active. And this is 192.168.20.101. Now, here's a good example. Notice, you know, I need to leave this like this. Here's the old machine trainer, which is called the Unfamiliar Machine. This one actually, because it needed a code name, it's called the Rogue Rig right now. I don't know, what do you think? Is that a cool name? But yeah, notice your controller names. We can have multiple controller names. So it is that one. I'm going to go online, and we're going to see what our I/O looks like. So, whoa. Now, I don't know if I've ever actually had that happen, but yeah, so apparently I set up everything good. And if we look down in our I/O, then one right now, we do have this I/O link module here. This actually is the old I/O link module. I wasn't sure how to do a few of the conversions to the new one, so I left that one in there just so I could work on the code. Now I'm ready to test my discrete I/O, the ones that are actually going directly to the PLC, which I was already excited to at least have one input working on it. Now here's where, let me show you a little easier way to do this than what you're probably thinking. So typically we would open up our controller tags, and yeah, even in our filter box up here, we know it's touching the PLC, so it starts with local. And I could bring local :1:I up, and I can sit here and brutally open all these up, or if you didn't know it, you can right-click local :1:I, and you can expand all. But all right, now I got a lot of back and forth, and I've never figured out a way to zoom into the controller tags, and I don't have a helper here today. So what I actually usually do is make a ladder diagram to do this, and I leave it in this machine trainer usually. So actually, if we open up our unscheduled, then there's a test routine here. And this has all of our inputs. And what I love about doing it this way is, first of all, we get a clear color change, but also we have the zoom button. Somebody one day has got to teach me how to zoom in the controller tags. I can't believe you can't do that. But so now I'm gonna be able to look at this and see what all is going on. And I'm gonna start with my buttons. And yes, there are no labels on our buttons. Don't worry, we're gonna do a little bit better than that. Here's the old machine trainer. So it was labeled. It has like left start, right start. But even here, you notice green light, yellow light, red light, blue light. And the reason they're labeled like that is we have different programs that we run in these machines. So sometimes maybe we're trying to simulate a lift station. Maybe next time we're trying to simulate a process control. So that's why the labeling's always had to be generic on that one. So what we're actually gonna do on this one is it's gonna have an overlay on it that can easily be popped off and a different overlay put on. That'll make the button labels. And I'm gonna try to put a little visual here of what it's supposed to be simulating. Our first one is the left start. And I look down, there's this one right here. So I press the button. Woohoo, all right. The next is pause cycle. That's my yellow button. Press it. Then the stop cycle. Uh-oh. Okay, well, right away we have an issue with the stop cycle, so I'm going to figure that out. All right, and then the reset cycle is the blue button. It's actually over here. It's good. And we switch to hand. Uh-oh, got that backwards. This is supposed to be hand. To the left is hand. And that's supposed to be auto, so I'm going to swap those two wires. There is our spare 1 button. There's our spare 2 button. And actually, e-stop's okay. Probably doesn't work yet, but I need to test that. All right, we need to look at those safety relays. Okay, the e-stops are out. Well, let me look over here at this e-stop. That e-stop was pressed. Ooh, okay. So emergency stop 1, channel A and channel B. I reach over and I press that. Both of those are working. This one right here is not working. Oh, wait. Oh, I forgot. On this one, while we have the safety inputs, I wanted it where we still could show how to troubleshoot e-stops that are in series. So I know a lot of y'all are just like, no, don't wire them in series. Well, we still have to be able to troubleshoot them in series. So I forgot. If I press this e-stop, that drops that out. Pull it back out. Or if I press this e-stop, that drops that out. So it was working. I just couldn't remember how to do it. Next on the side of it, we have our 2-hand controls. And I press that. I should see our left. Uh-oh. So these two didn't work. Let me try the right hand. Yep, those two aren't working. And well, good thing I added these little thumb screws. That way this would be easy because I want them to be able to work on this too. So we'll pop that off. Slide it in there. And we'll put this on 24 volts. And first of all, do I have power? Yes, I do. Well, that's kind of a lame check because whoops! Well, there you go, real life. That was a lame check, at least before maybe I just jerked all the wires out of it because the light was on. Put this back up here. Apparently I'm gonna need a little ledge to hold that on. So now the question is, what am I getting when I press the button? So I'm gonna go between the 0 volt and one of my switches. Oh yeah, this is gonna get tough with one person now. Will they just gravity just happen to leave them there? I can reach over here. Oh, yep, it does work. All right, in typical startup fashion, that is local colon 5 colon IPT00.data. And I noticed we added a few things and we were getting really tight on safety IO. So I came back and added another safety module, and yeah, I ain't even wired it up yet. So now the question is, can I find a connector for that? Now we're in the training center. I could always steal one, but let me see if I got a. So technically I did not have one in my stash, and I didn't want to steal one off of one of my trainers. So yeah, I need to invade Mary Bruce's room where she builds trainers. And we got one right there we can steal it off of. Ooh, aha. Yeah, Mary Bruce isn't here, but that's all right. I'm gonna find it. That looks like what I need. Okay, so apparently I have an unplanned learning opportunity. I have my wires on it now. And the way these buttons work, you get one normally open, one normally closed. So this is the normally open. Actually, go to the normally closed. That way it's easy to see. We have 24 volt. Let me get the wire out of the way. There we go. Got 24 volt. I put my hand over it, and it drops to 0. And on the opposite side of it, I put my hand over it, and I get 24 volt. But I have no input lights. And what I think's happened is I added this module, but I didn't configure it. So I'm going to go up here to number 3. And if we go to its input points, then yeah, this one is configured. Oops, well, we're going to need those configured soon. But this one was already configured. I just added these two. But if we go over here to this module, point mode is not used. So on these should be safety. I'm not doing a pulse test on these. And then we hit that apply button. Gonna get a warning. And gonna get another warning. And now we have inputs on it. So now inputs 0 is off and 1 is on. I stick my finger over it and those swap. And same thing on the right side. Yep. Okay, I've got a little bit of an angry output module, but mainly all of my safety inputs are working. I think they're all set. So I think we're just looking for a safety reset. So hopefully when I press this safety reset, we get some lights on. All right, now I only got one of my safety relays, and I was trying to do this NPN, PNP type safety setup. All right, so it's been like 2 hours since I hit the record button last time. In fact, I should have put a clock on this thing. Well, I started at 8 o'clock this morning. It's 2:45 now. And yeah, you know, sometimes you got to call in reinforcements because I couldn't figure this out. So what I was trying to do is a lot of the technicians that come here say they really struggle when they see this type of setup on their safety. So we have a sourcing output going to one of our relays, and you have a syncing output going to your other relay. And I sat in here and I tell you, I messed with every single combination possible of these. Because I knew, you know, when it was talking about dual, I thought, oops, and like, notice now you can't even select dual. But normally there's a dual or a single mode right here. But what I didn't realize is you have to go up to the general tab, and if we go to change, then right here, it defaults to sourcing, and we need to go to bipolar mode. And I had to thank my buddy Jeff Kuiper with Full Circle Automation for telling me that. Because yeah, he's like, no, you can't do that. You got to put it the whole module in bipolar mode. And I'm like, well, I'm using a lot of them as single channels. And he's like, yeah, that's perfectly fine. So the only difference is now with this output, we have 2 flashing on it. But if I hit my safety reset, then now all my channels light up, and I have both of my modules lit up. And mainly this gives them an opportunity to realize on this one, this is what we call, I guess you'd say the typical way, is we're putting plus 24 volt from our output, and A2 is going to our minus of our power supply. Well, this is a sync and output. So we are actually taking our plus 24 volt to A1, and then A2 is going up to our output module. And all that work to really get us to where we can finally test our output. So this is our output module. I pressed the E-stop. We see it was dropped out. And yeah, now with that safety relay working, That gives us our outputs. Maybe we have a flashing light up there. We're going to test it in a little bit. And that gives us our 2 air dump solenoid valves, which now means, hopefully, got pressure here. I believe we probably have pressure here. So now I need to get the I/O link up and going so I can get pressure to these solenoids to get that moving. But let's test the rest of the outputs, then we'll come back to this. So super exciting. I started testing my outputs and finally stuff is working. So I switched that over to hand. We got a hand flashing. Switch it to auto, that one's supposed to work. These work. Our linear actuator right here. Yeah, you know, the old one had an indicator on it. If we look over here, there was a pointer on this one. Now, I don't know. That may be unrealistic though. If you got a big valve, not all of them have indicators. What do y'all think? Should there be an indicator on this to let you know that it's open and closed, or if the ball doesn't go up, you figure out that it's closed? Okay, so very exciting to get a light on, but no, it's more than a light on. All the I/O link is tested. I ran into one hitch. So compared to the old I/O link, all the bytes were swapped on this, which usually isn't a big deal. In fact, if we look at this stack light AOI right here, there is a swap byte right there, and you just stick a 1 in that and that would fix it. But here is the condition monitoring, and there is not simply a swap byte on this add-on instruction. So actually I got kind of, you know, my brain's kind of fried, so I need to think about this one, but I'm trying to figure out, I'm thinking this is probably a case for a kind of before next loop, but I need to swap 40 spots here. So that seems like a really good place to stop for the day. Because really, what do I have left to test? I gotta test the motor, but I assume the motor works. That part's just, of course, there I go assuming. I assumed a lot today. But hopefully I can get this finished up enough before the next class. Because here's the bad part, and actually it's the same as when you're working on equipment. If I don't have this fully ready to go or really close to it, I gotta pull all the parts off of it that I robbed off of this one and get it back going for the next class. I'll see you later.